점수 잡는 hackers.
Hey, welcome back. This is Digital SAT Math Orientation. But before, I hope you had the chance to see the previous lecture one, What is Math? Because that's a fun lecture discussing the philosophies, basic ideas and skills in math, as well as how math is relevant to life. Once again, my name is Junie, available to you anytime, anywhere through these videos, and I'm thrilled to be your guide on this exciting journey. So, whether you're seeing the digital SAT math for the first time or brushing up on it after a few tries, it's absolutely critical to know the ins and outs of the exam. So, welcome to the orientation. And before we get started, I'm going to take you through the agenda for today, and we'll talk about everything that's required for you to know on the math section. Let's get started. So, this is the agenda. We'll have the math section overview, where we talk about testing format and the directions and references that are provided in the exam, so you won't have to spend extra time during the exam to get to know those and read those. And next, we'll get into the second part where we talk about the 4 big ideas or concepts on the section, such as algebra, advanced math, problem solving and data analysis, and geometry and trigonometry. Great, let's get started. So, digital SAT math is a 2-stage adaptive testing. And in the first module, it's going to be a broad mix of easy, medium, and difficult questions in that specific order. And it will have a total of 22 questions that you'll be given in a time period of 35 minutes. In the second module, that's going to be a targeted mix of questions that's actually based on your own performance on Module 1, which means for students who've scored pretty high or have done really well on Module 1 will get a relatively harder level or set of questions. And for the other students who've done about on average or maybe not so great, we'll get an easier level of questions for Module 2. Same format, 22 questions in 35 minutes. And what's really interesting, though, is that College Board has decided to put out there 2 questions per module, or 4 questions total, that actually won't count towards your score. What that means is that it's probably going to be experimental sets of questions. Since they won't count toward the score, some students ask, well, can I not do those? Well, the problem is that we will never know which of the 2 questions out of 22 or 4 questions out of 44 of these will be the experimental ones. So, I think it's going to be in our best interest to do our absolute best for all of the questions that are provided. Now, total, overall, after we've done the 2 sections or 2 modules, we'll be given a score between 200 and 800. Again, total of 44 questions. And because the total time is going to be 70 minutes, probably on average of about a minute and a half. But again, these are not 70 minutes given straight, but 35 minutes each module. And only after you finish Module 1, we'll proceed to Module 2. So this is a general overview of the 2-stage adaptive testing for this section. Now, we've done a little fun experiment here. And so let's think. We have 2 student scenarios, A and B. And although these are going to seem a little extreme conditions, we've decided for student A that, student A has scored 0 or has gotten, all of these wrong on Module 1. And probably based on that, the Module 2 level of questions will be on the easier side of things. And assuming that they've actually done really well on Module 2, this predicts about a score of 410. And now in student B scenario, it's actually going to be the opposite, where they've done absolute best or got everything right in Module 1, and then in Module 2, got nothing right. And then this came out to be a little higher score. What this tells you is that, in fact, your performance on Module 1 is a little bit, or if not more, important than Module 2. So, I'm hoping that most of the students will end up, would score something like these 2, but in case, if we do end up somewhere in between, right, it should be kind of reflective of the fact that, again, Module 1 performance is a little bit more important, okay? All right, moving on. Now let's talk about question format and some of the question style, as well as the percentage of the section makeup. There will be 2 types of question format. The first one is going to be out of context, which then kind of assigns what we call pure math scenarios or pure math questions. These are just going to be numbers, equations, functions, and that's it. All you have to do is just solve for whatever it's asked. It's about majority of the questions, right? 70%. Now we have in-context questions, which sound a little scary and maybe a little, a little long, but these are brief scenario of topics from social studies, science, and or real-world settings. Now, students might think social study, well, it's not another subject apart from math. But again, no prior knowledge is required because these are just simply math situations that are within the context of these, social studies, science, and real-world settings that all we have to do is be able to translate the verbal statements that are given in the word problems to math expressions. Once we get through the questions and get to the section, right, whether volume 1 or volume 2 of these questions, you'll know what I'm talking about. So hang on tight. All right, next, onto the answer stages or answer types. So again, there will be two. The first one is going to be the 4-option multiple choice. Sounds easy, right? Because all we have to do is just choose a single correct answer among A, B, C, D options. And these will constitute about 75%, about 3/4. And then the rest, what's called student-produced response, or SPR. It's going to be where a blank is provided for a free answer input. So in other words, no options given. We would have to solve the questions and then kind of come up with our own answer, right? So there's not really going to be a guide or, selections to choose from. And that's going to be about 1/4 or 25% of the exam. Now, let's take a brief moment to go over student-produced response directions. Because, if a blank is given and it's going to be a free answer input, sometimes we wonder, how are we supposed to formulate our answers appropriate for the exam, right? So let's take a look. If you find more than one correct answer, enter only one answer. Kind of obvious because there's only going to be one blank provided. So if there happens to be multiple sets of answers or solutions, just, provide for that one answer. Next, you can enter up to 5 characters for a positive answer and up to 6 characters, including the negative sign for a negative answer. And by characters, they mean to include the decimal point, the fraction slash, everything, including the numbers as well as those symbols. So, and I'll give you some of the examples later. Now, the next set says if your answer is a fraction that doesn't fit in the provided space, enter the decimal equivalent. So, for example, or also known as, so this is about 1, 2, 3, 4, 5, 6 characters for a positive number. So in this case, because they only allow up to 5, it's better probably to convert this to a decimal and then inputting that into the answer sheet. Next, if your answer is a decimal that doesn't fit in the provided space, enter by truncating or rounding at the 4th digit. Now let's think about what kind of decimals won't fit in the space provided. So we have about rational and irrational numbers. So in the case of irrational numbers, right, which have infinite or potentially really long sets of digits that follow the decimal, we want to be able to truncate it or round it at the 4th digit, including the leading 0. So in the case of right, that's already 1, 2, 3, 4, 5, 6, 7 characters. So the 4th digit would be 1, 2, 3, 4. So, you would be able to truncate it there, but make sure to round, right? So then this would be equivalent to, like that. Sometimes you could actually avoid the leading 0, right? And then get rid of that and just do decimal point, and also works just fine. Okay, great. Next, that says if your answer is a mixed number, such as 3.5 or 3 and 1/2, enter it as an improper fraction where the numerator is actually bigger than the denominator. Most of the case we would have to resolve those because we can resolve it to like a mixed number. But in this case, and I'll show you why this might serve as a confusion, it's better to leave it as an improper fraction or its decimal equivalent. So let me show you. This is easily read as 3.5 or 3.5 or 3, 1/2. But sometimes when they say up to 5 characters are available, there's not really a character for space. And even if there were, we would not be able to indicate, right, that this is in fact equivalent to that. So in this case, what they recommend is, leave it as improper fraction to avoid the confusion, or convert it into decimal place. And lastly, don't enter symbols such as %sign, comma, or $sign. A lot of the word problems that are going to be administered in the exam will sometimes include units like $signs or kilometers or centimeters, and other mathematical units. So make sure to leave all of those out and just get the numbers inserted. Now, this chart kind of gives you that overall summary of what we discussed so far when it comes to student-produced response. So again, in the case of 3.5, or if we happen to have this as our final answer, these are the reasons why it might not be such a good idea to try to leave it like that. Because again, the answer can be misread as 31 over half, or 31 over 2, or 31 halves, right? Again, we kind of wanted to communicate the fact that this is 3.5, not 31 over 2. So these are all possible answer options. Now down here, we already discussed how there are only going to be 5 characters total, available for the rational numbers or for the answers. So make sure, including the decimal point, that our character count comes out to 5 characters. In the case of negative, they do allow 1 extra character, right, up to 6, including the negative. So same deal up here. So make sure your total characters are going to be, based on whether it's positive or negative. And then finally, no dollar sign, that's, included in the answer, and no comma signs. So if your answer comes out to be something big like this, just make sure to leave the comma out and, keep track of all the digits. And lastly, percentages that can be a little confusing just because if we leave the percentage out, right, 60%, without this percentage actually comes out to be 60. But remember, percent means, in language, per 100. Again, cent, right, which means 100. So really, 60% is also known as 60 over 100. So you better not leave the answer just as 60 because we would have to convert this fraction to either a simplified form of the fraction or a decimal place. Alrighty, thanks for staying on. We're still in the digital SAT math orientation. In this part 2, we'll talk about calculator use. So in the previous part, if you haven't had a chance to see it, we discussed types of question format or the structures for the questions, as well as what type of content domains or big 4 areas of the categories of math, subjects that are going to be tested on the digital SAT math. Here, it's simple, short, a math calculator use overall overview, but in this case, I have some really nice news, so better stay on and we'll talk about how to use the calculator for the exam. So first of all, you have 2 options given. Number 1 is that you can bring your own approved calculator, and most of the ones that we use for school and for general household purposes should be approved. But if you really wanted to check, make sure you go on collegeboard.com and check out the list of approved conditions for your own approved calculator. And number 2, we have what's called a Desmos graphing calculator that's actually embedded in the digital system for the SAT math experience. Today we'll probably work more with number 2 because everyone has equal access to that, and because we have equal access in case our calculator fails us during the exam, the battery runs out for whatever purposes, we can always rely on being comfortable with Desmos graphic calculator. So let's move forward. So this is going to be the exact screen that you'll see on the day of the exam. If you hit the calculator option, so given the graph portion as well as some of the answer inputs they can, the answer buttons they can use down here. So not only for graphing, but for computational, for statistical, for general mathematical computations, you're able to utilize the function. If you hit functions here, the screen will be populated with various functions, or in this case, mathematical computational expressions such as, mean, median, minimum, and maximum, and quartile, quantile. And of those, I've only brought up probably the most common ones that you'll use. So let's see. In the case of trig functions, we have sine, cosine, and tangent. And better remember where you have to use those, right? In the trigonometry section where we deal with triangles. So in the case that you have to do, sine of 45 degrees or cosine of pi, you can, again, use your own approved calculator, but in case that fails you during the exam, it's always good to know and be comfortable with what's provided in the decimal calculator option. So click function, it'll populate with the trig functions, and whether you have to calculate sine or cosine, there you have it. Now, in the case of statistics, sometimes the digital SAT math will ask for things like mean of a set of numbers. So let's take a look. So if we had a set of numbers like this, from 2, 6, 10, 12, 20, and the question asked for the mean of the set, it's probably a good idea to know the definition of a mean, right? In this case, take the sum of all. And one more step, divide by the number of terms, right? In this case, 5. So you can simply use a calculator to, take the sum of all the sets of numbers and then divide by the number of terms, 5. And then this will still give you the mean. But in case, with the awareness of the fact that you can actually use this mean statistics function on the Desmos calculator, all you would have to do is just click that and then put in these numbers, and then it'll actually give you the exact same mean. Remember, math is a journey that takes us from the question that's given or administered on the exam to the set of solutions. Even though it might seem very convenient and very easy just to be clicking on the mean button and say, hey, give me the mean of this set of numbers, I think it's a little worthwhile to actually know how to solve it manually by hand first. Because in that case, when we are in life situations where we don't have access to calculators like Desmos or our own approved calculator, it's always important to know how do we find the mean of a set of numbers, right? Same thing goes for things like median and minimum and maximum, which in this case, the minimum is 2 and maximum is 20. So again, it's always really important to know and be comfortable with the use of calculators, but if you have the chance, let's see and let's explore what these definitions such as mean, median, minimum, and maximum really mean in math by hand. Now, before we move on, if you also click this letter ABC button, it'll take you to the next keyboard, which gives you all of these variables or letters in italics. Remember, we talked about in the previous lecture how in algebra and advanced math, as well as word problem sections, that there will be questions or equations and functions in multivariable. So in the case of one variable, it's simply x, but in the case of two variables, we'll have x and y. So anytime they want to be able to graph or find solutions or work with multivariable equations or functions, always, click on to the next set of keyboard, and this gives you not endless, but the number of alphabet, wise, all the possible letters that you can use for the variables that are presented in the questions. Question 19. What is the solution to the given equation? It's pretty simple, right? All we have to do is just isolate x on one side and then get everything, all the constants to the other side. So let's do that. Again, working with the square roots, let's square both sides. And isolating the constants. So then just that one last step where we divide both sides by 2. That gives us an x value of 19, and that was pretty simple, right? Question 20. It says the function f is defined by the given equation, and this new function g of x is going to be a shift within f of x, which is given as f of x minus 3, which equation could be defined function g. So all we have to do is substitute anytime that we see x for f of x minus 3. So let's take a look. So instead of x, we would use x minus 3. And every time that we saw this variable x, x minus 3 would go in. So let's span this top quadratic equation out. Okay, keep going with the getting rid of the parentheses. again, just that one last step. Okay, actually, second to last step, because we would have to combine the like terms. There we have it. So let's just double check, right, that everything is accurate. For questions like this where it involves multiple long kind of carrying over process, just make sure all your arithmetics, all the additions and subtractions are accurate. So in this case, we got down ourselves to 5x squared minus 47x plus 102, which actually exactly fits our answer C, right? Phew, great. Let's move on. Question 21. A museum has a rectangular parking lot with a length of 270 feet and a width of 150 feet. The museum wants to increase the area of the parking lot by adding the same distance, x, to both the width and the length of the current parking lot. Which equation represents the new area with the additional x on both sides in square feet of the parking lot after the expansion? So let me draw this for you. So in the first initial case, we have the given length of 270 feet and a width of 150 feet. Certainly not drawn to scale. So the museum parking lot would look something like this. But then in the second scenario, or this new added scenario where they're adding x, which is the same distance, to both the width and the length, and this is a representative of what they've explained, right? With the addition of the same distance x to both the width and the length of the current parking lot. Now they're asking for the new area A in square feet. Remember the definition or the formula for an area of a rectangle would be the product of length times the width. So simply the length times the width. So we would actually multiply the 270 plus x and 150 plus x. And that would give us the answer D. Great. In this case, because we're dealing with a variable x, we didn't really need to worry so much about the units given, right? Because we're not solving for that exact value of the total area. But in the case that we do, make sure that the units stay the same from the beginning to the end. Alrighty, on to our last question. 22 says, Kate is looking up at the city's tallest tower, and the tower is 1,450 feet tall and is perpendicular to the ground. The measure of the angle between her location on the ground and top of the building is 30 degrees. Which expression represents the distance in feet Kate is sitting from the tower? So just a quick glance, given all the options, it seems that it's expressed as sine, cosine, or tangent. So potentially a triangle is involved here, but let's take a look. So first, let's draw Kate, represented by, this lovely stick figure, and we'll draw the building. And this, the city's tallest tower, is 1,450 feet tall, which means from the height, or the top to the bottom, is about 1,450 feet tall. And because the measure of the angle between her location to the top of the building is 30 degrees, we could probably draw this as, so this angle being 30 degrees. Now the question is saying which expression represents the distance in feet from Kate to the bottom of the tower. And we're going to call that x. So, as given here, this is indeed a right triangle. And anytime that we work with right triangles, let's always remember SOHCAHTOA. So, in the top case, sine, which is equal to opposite over hypotenuse. In the bottom, cosine is equal to adjacent over hypotenuse. And lastly, tangent is equal to opposite over adjacent. Again, a quick glance, right? This is the hypotenuse here, but because we're not really working with the hypotenuse, we can probably eliminate, or not use sine and cosine, because all we're given here would be, the value of 1,450, which from the perspective of this 30-degree angle is the opposite segment, and then we're asked to solve for x. So in this case, kind of the three formula, we can probably use tangent. So tangent of 30 would be the opposite, which is 1,450, over the adjacent, which is x. So let's see if I can express that. And a little bit of this rearrangement around the given formula. There we have it. So this segment x is, using one of these three equations, is going to equal, which is, the height of the building, which is 1,450 feet, over tangent of 30 degrees that's given. So the answer is going to be A. Great. Now this wraps up Module 2. And again, for every module, I organize the number of questions that can be categorized into one of these 4 content domains. Always remember, at the end of each module, always check, what is my weakness? Where am I struggling the most? So in this case, we had seen a little bit more of the advanced math questions than usual, but just check. If you're ever struggling, always diagnose, which content domain am I struggling the most with? And I'll see you later. Hey, it's a good day to get some math practice in. So welcome back to our new Digital SAT Math Volume 1. We're heading strong into Test 4, beginning with Module 1. Let's get started. Question 1. What is a solution to the given equation? So in a case like this, let's think about how we want to simplify the equation before we have to put these into the calculator. So first, we want to simplify the fraction by multiplying both sides by 80. So that allows us to cancel the denominator, and then we end up with so you can leave your work like this at this point, or you can simplify it by, plugging the product into the calculator to get 3,600. Now let's think about how we want to get rid of this x squared value to solve for the value of x. So in the case of an x squared, we want to take the root of both sides. So then this simplifies further down into either of these methods or approaches to putting things into the calculator will give us positive or negative 60. But as you can see, all of our answer options are all positive values. So that means the answer must be our positive 60. Great. Question 2. If minus 2x minus 2 plus 11x is equal to 16, what is the value of 6x plus 1? Again, let's solve for the value of x. So in this case, starting with what's given in the first part of the question, let's try to combine all the like terms and get all the constants on the one side. So there we have it, and this yields an x value of 2. Now, that's not the end, and as you can see, the answer does include 2 as one of the options, but the question is ultimately asking for us to get to solve for the value of 6x plus 1. So we must plug the value of 2 for x into 6x plus 1, which yields 13 as our final answer. So the answer is going to be C. So be careful when sometimes in the middle of the process or in the middle of solving for these steps, such as an x value of 2, they might include it as a trick answer in the option. So really watch out for, again, what the question is really asking in the end. On to question 3. The total length of roadway L in miles to be laid by road workers is given by the function L of D, and that's going to be negative 4D plus 60, where D represents days the workers worked. If the workers worked for 12 days, how many more miles of road remain to be laid? And what's really interesting about this question and the information given in this question is that the total length of roadway L represents the number of miles to be laid by road workers. So let's bring this equation down. And let's imagine for a little bit, if D were to be 0, which means it represents the days that the workers worked, so 0 means none of the days or the starting day that the workers have begun to work. In that case, this L of D, or L of 0, would equal 60. So at the very beginning, this represents the number of miles the road workers have to, get their road laid. Now let's try L of, in this case, 12, because D represents the number of days the workers worked so far, and the question is asking us to find the number of miles of roadway remain to be laid for 12 days. So keep on with the arithmetics. Okay, so that gives us a number 12, which then represents, at day 12, the remaining number of miles the roadway workers have to work to get their miles laid. It would be 12, which is the answer. But again, this is a very interesting fact because let's think about this for a second. We started with L of 0, which is 60. So again, at the starting point, they had 60 miles to be laid. And then at day 12, they had remaining 12 miles. So as you can see, every day adds the work done, and it contributes to the total number of miles that has to be done. So every day, L of D, which is 1, L of 2, L of 3, L of 4, that's going to keep decreasing the number of miles the roadway workers have to work on. On to question 4. The dot plots represent the distributions of values of two different data sets, A and B. Which of the following statement is true? So it seems like our range is pretty consistent from A to B. We go from 12 to 18, and that's the same for data set B. Now, if you look at the distribution or the shape of the graph, it's a little different. And let me draw that here for you a little bit. So it seems like here, a lot of the data points are focused more on the minimum and the maximum side of the range. And down here, it's kind of a graph where it's a little bit more evenly distributed, right? And we have definitely high frequency in the middle. So kind of looking at the answer options given on the next page, let's take a look at A, B, C, and D. You probably now notice that the statistical value or the statistical term that they're wanting us to evaluate is the median. A says the median, B is the median, C is the median, and D is the median. So let's go back and take a look at what the median means and how we can speculate, where we can look to find the median of the two data sets. So in the case of data set A, again, we go from 12 to 18, and same thing for B, 12 to 18. The definition of median is the exact middle value. So in a case where the data shape is pretty symmetric on the left and right, the median would be right in the middle. So I would probably suggest looking around here. So 15, and same thing, 15 for data set B. Because again, the left and the right side of that value 15 is pretty symmetric or pretty the same, and same thing for data set B. So as you can see, going back onto the next page for all the options, let's look for an answer where they're saying the median of data set A is equal to or pretty consistent with the median of data set B. So this one is talking about data set A is greater than B, so maybe not our best answer. B talks about the median of data set A is equal to, so okay, so this one potentially. C, the median of data set B is greater than the median of data set A. So again, A is talking about A is greater than B, C is talking about B is greater than A. And then D, the median of data sets A and B cannot be determined, but we kind of, estimated the approximate value. So in this case, the best answer is probably going to be B. Great. Question 5. If f of x is equal to 3/7 times x plus 10, and f of minus or negative 21 plus k, so now we have a new variable here, is equal to 6. What is the value of k? So before we get into this part of the question, let's bring this down. So from this, we can plug in the value of negative 21 for x. So anytime that we see x in the equation, we want to be able to substitute that with negative 21. So again, let's go ahead and simplify this fraction. So the value of f of negative 21 is going to be 1. Now, that's not the end of the question, right? Because they're saying, well, we want to add k to that, and then that will yield 6. So then bringing this up here, so again, keep doing the algebraic work. So then k is going to be value of 5. That's it. So again, similar to what we kind of worked on earlier, if there are multiple components of a question, always remind yourself, I gotta ask myself, what is the question asking? And not just solve for the value of x and be satisfied with that. Okay, question 6. The triangle A, B, and C is similar to triangle D, E, and F, such that A, B, and C, so points A, B, and C correspond to points D, E, and F respectively. So A is congruent or it corresponds to D, and then B is congruent to E, and C to F. If the measure of angle C is 56 degrees, what is the measure of angle D? So our given fact, angle C is 56 degrees. And then they're asking for the measure of angle D. So whenever two triangles are congruent, or in this case similar, we can be rest assured that all the angles are either the same or what we call congruent. So in this case, the measure of angle A is going to be the same as measure of angle D, and B with E, and then C with F. So then also, given the fact that C is 56 degrees, F is always also going to be 56 degrees. Now, from this is just simple math, because we know that the total sum of all the internal angles of a triangle is going to be 180 degrees. So we know that one of them is going to be a right angle. And I'm going to call this x, which is going to be that missing angle value. And if this is equal to 180, the value of x is going to be 34 degrees. Now, again, whether it's A or D, we did the same math because for similar triangles, the corresponding angles are congruent. So in this case, whether they're asking for the angle of A or D, the answer is going to be 34 based on our arithmetic math. Good.
토익은 해커스, 영어도 해커스, 고득점 메이커스, 만점을 받아 버렸어. 토익은 해커스, 영어도 해커스.